Thank you, everybody, for joining our RVNUG user group today. We appreciate having you all join our little group. We continue to have our online meetups until we return back to physical presence. But until then, we bring you guys great content and speakers, and today is no exception. We have Sean Killeen presenting today on the joy of functional testing with Specflow. Sean is a principal technical fellow for modern software delivery at Excella, originally from the Philadelphia area. He is a Microsoft MVP with 15 plus years of experience solving problems for commercial, nonprofit, and federal clients. He currently is the lead of the Unit Docs project. In real life, you can find him enjoying being a dad to a toddler, fiddling with OSS projects, sipping great beer, patiently waiting for the pandemic to end, or singing somewhere. Yeah, that's awesome. You sing too, Sean. You just do it all.
I'm a theater kid.
Oh, wow.
It's in my nature.
Oh, so you like really sing, like not just sing in the shower kind of.
I've been paid to perform a musical before. Like it's only one, but it was
very impressive.
It's always been a love of mine.
Impressive. Digitally, you can find him on Twitter at SJ Killeen, or blogging not nearly enough at SeanKilleen.com. He doesn't bite, so do say hi. Thank you again for joining our group today. Take it away, Sean.
Sure, happy to be here, and thank you for having me. It's really nice to be here. And I mentioned lately in terms of the blogging, not enough. I've finally been able to get out of that rut, and so one of the things I'll encourage folks to do. I don't have a slide about it here, but I recently released a blog post with the results of a survey I had conducted for open source maintainers in the .NET community. And so one of the things I'm looking to do, that survey explored ways that we can better support open source and open source maintainers in the .NET community. So one of the things I'm looking to do is to turn that into some action. And so I've got some suggested actions, and I'm working on some impact maps there based on that. So I'd love for you to join me there. If you've got any input on specific actions or other insights that you might have gotten from the survey data, I'd be happy to see that. Feel free to drop a comment there or contact me. But looking to move that forward to see if we can help open source in the general community. So just wanted to point that out. As Tolga mentioned, I'm from Excella, so we'll skip that slide, but I'm happy that they're here. They allowed me to be here, so really happy with them, and we'll leave it there. I also like to give a shout out before I talk to the .NET Foundation, which supports a lot of virtual meetups, supports a lot of different content, and supports a ton of open source projects in various ways. So if you're looking to get involved with open source, or you're looking to get involved in the community and starting to give back, the .NET Foundation is a great first stop for that sort of thing. So if you've got any questions about connecting with the .NET Foundation, I'm a member of one of the maintainer working groups of the .NET Foundation, but I really just like to put a plug in there because it's a great place to get involved, and I'm always trying to see if I can help everyone get involved a little bit more. So if you're interested in that, feel free to drop me a message after this as well. As we mentioned, hi, I'm Sean. It's my Twitter, my site, and as I mentioned, I work for Excella, so no need to say more there. So let's jump right in. We're going to talk tonight about functional testing, or some might call it acceptance testing, with a tool called Specflow. So we're going to talk a bit about why does this matter, what are the impacts, what's a need for this sort of thing, and we'll talk a little bit about specification by example, the impact that it has, the need that it fulfills. We'll get into the concept of what does it mean to do functional or acceptance testing. We'll talk a bit about the Gherkin syntax and what that means. We'll talk about some benefits of things overall, and then we'll jump in for the second half to do some Specflow demos. At any given time, if I'm in the middle of talking, feel free to interrupt. I don't know that I'll be able to see the chat, so other organizers will also give you permission to just cut me off wherever. It's fine, doesn't matter. I'm happy to answer questions either now or at the end, whatever the organizers prefer. All right, so sound good? We'll jump on in. All right. Great. So let's talk a little bit about why this matters. So, and I'll start with one of my favorite, XKCD comics. This is the comic, for those of you who aren't seeing it, is my motto is move fast and break things, with a long list of jobs that someone has been fired from as a result of that. And really, I say this to underscore the fact that in our industry, we don't get to be early days of Facebook. We don't get to move fast and break things, right? We have to move fast without breaking things. And we need that confidence to be able to move forward quickly to deliver value for our customers. So breaking things is a luxury we don't have. So sometimes in our industry, and I'm sure you've never experienced this, but sometimes in our industry, there might be confusion about a requirement. You may have an idea of a requirement, and your stakeholder or customer may have a different idea about a requirement. What does a requirement mean? Maybe we have implicit understandings of what things mean, right? So these can cause confusion. This can cause work to come back or cause additional churn in our process. It can cause all kinds of delays, and it can kind of really be one of those time thieves that kind of gum up the works in our delivery process. So then confusion about requirements or implicit requirements is typically or often a cause of that sort of confusion. Similarly, trust. When we have regressions or things break, it erodes trust. Again, I'm sure this has never happened to anybody, but I'm sure you've not been on a project where someone has said, "Oh, everyone's afraid to touch that code." right? Everyone's a little nervous. Everyone's a little nervous to touch that. Like, you can tweak that, but maybe set aside a month for some testing on that because it's real gnarly, and everyone is a little afraid of it. So I'm sure you've never had that, but it does happen now and again. So stakeholders can't necessarily make sense of the automation that we have as developers, even when we write it. They look at it and they say, okay, that's great. It means nothing to me. I am a human being, not a machine. I do not know what you were talking about. And so this can erode confidence, right? And when that confidence erodes, that also kind of destroys our feedback loops on our pace, because now we've kind of introduced, again, back to that uncertainty in the process of we're not, everyone involved in the process is not necessarily confident of what we're doing. And when that happens, it's sort of like, well, we'll do some extra manual checks. Oh, we're going to have to kind of just look over things in general for a little bit. And we don't have that confidence to be able to close those feedback loops quickly and regularly. So again, waste, a lack of value, right? And also, typically speaking, that's not the most fun work to be doing either. So it's not exactly engaging for any of the people involved in doing it. So trust allows us to build meaningful value loops for the business, and allows us to gain confidence that we can respond when we get their feedback as well. So that trust is important in this. Also, another example where this might be relevant is the idea of feature fighting. And this is a term I coined. There may very well be a better term for it. But the idea that I'm not sure who's ever developed a feature where you develop a feature, and then some months later you're developing a feature and your tests fail, and you look at your tests and you say, well, the tests are correct, and it's because actually a different stakeholder has a different idea of how the application should work, right? So you could remove those tests and change that behavior, but your two different stakeholders might have, or your stakeholder and their past self may disagree on what the application should do from a feature level, right? So we have this happen, building something as a team, it can break because of someone else's requirement, right? So this can be difficult to find in some cases, because unit testing and even integration testing to an extent doesn't necessarily surface the intent of a stakeholder in an appropriate way where these sort of things could be caught. So you may end up with some back and forth, or again, some erosion or lack of trust. Hey, we fixed this over here and this other thing breaks, and the dev team says, well, it's not, it's not what we did, but it's it's really not, it'd be better to just be confident about it. So similarly, how do we know when something is complete? Right, we're signed off on, in a lot of cases, if you have a development process and there's a stakeholder involved, there's some sort of sign off or some sort of agreement that yes, the work the team has done is done, it's ready to go to production, it's been accepted. So how do we, when we lack collaboration, right, thinking about done can be hard, right? How are we defining what done means? So a lot of times when we write user stories or when we write requirements, there's a lot left to interpretation around what is done, and it can be difficult for teams to get on the same page about what it means for a story to be done. Or I don't know if you've ever had this happen, but it's the equivalent of someone saying, well, this house isn't done yet because I want a pool. Right? It's not that the requirements haven't been met. It's that some additional maybe things have snuck in. And we like to adapt to change and harness change for the customer's advantage. But when we don't know that that's happening, or when it's happening excessively, it can still cause problems. Right? So we want to be more explicit, and we want to enable collaboration and better equipped, faster feedback loops. Right? And so this form of automated testing, really automated tests in general, are your safety harness, right? They enable, a safety harness is what enables the team to move quickly and with confidence, right? You can think of all these different tests as a strand in your safety harness, right? The more strands you have in your safety harness, the stronger it is, the faster you can move, the more confidently you can move. So we had unit tests for a while, we had integration tests, but then a book came along, specifically this book in particular that I love. The idea of behavior-driven development came along. And behavior-driven development, or BDD, in a lot of cases was about making unit tests, standard unit or integration tests, read a little bit more so that humans could understand them, right? So typically in a unit test, you might have a test named, method name underscore when situation underscore then expect this, and that's great if you're used to that convention or if you're not a human, but it's not necessarily good if you're not as familiar with it. So BDD kind of came along and then tried to say, okay, we should rewrite some of those tests to be a little more human readable, or read maybe a little bit more like a sentence, and change the structure of our unit test to express that. So when we see our tests run, we can kind of see a sentence being executed. And so along came the idea of specification by example. This is by an author, who also wrote the book on impact mapping, a pretty influential author as far as I'm concerned. And the specification by example movement talks a lot about creating human readable sentences where your requirements are expressed as examples rather than as requirements. And there are several advantages of doing this, but the idea is that you give one or more real detailed examples to explain functionality. So rather than just saying the system shall or the system will do a thing, you say, okay, well, when I do XYZ, then the system should do, so on and so forth. So this also is kind of rooted in how we communicate with each other. So when if I'm talking to you and I'm confused about a concept, what's one of the first things I'm going to say? It's probably, can you give me an example? can you give me an example of that? Our brains work very well when given concrete examples of things to process. They add a lot of clarity, they force us to be specific about our intentions, and they kind of create a shared mental model for how to express those kinds of requirements or those concepts. So in come the idea of functional and acceptance tests. So and I say functional acceptance tests because some people call them one, some call them another. I don't get too hung up on the terminology, and we'll talk about sort of the style of testing that I'm talking about. So it should be evident in a little bit. But some folks call them acceptance tests, some people call them functional. But the bottom line is, you may be familiar with this this 4-box diagram from Brian Merrick. I think it's from from a little while ago, but if you ever want to get famous, right, create a box with 4 quadrants on it that you can shove things into, and it'll hang around for a while. So what Brian did is he came up with the idea of some quadrants around automated testing. So on the top versus the bottom, we have business-facing tests, which means tests that are available to humans outside of the dev team. They're tests that a human being can understand, versus technology-facing tests, which are tests that are written primarily to be executed by computers. Now, on the left-hand side, we have tests that support programming, meaning we have built the thing as we intend to build it. And then on the right, we have tests that critique the product, or rather, the product behaves in the way that users or our stakeholders expect it to behave. So functional acceptance tests kind of live, right on the, probably a little more towards the middle, and that some of them critique the product as well. But essentially, they support us saying that we have built the thing in the way that we intended, and they do that by representing tests in a language that human beings can understand. So, in this case, it's going to be human readable, in this specific case, English language tests. So, and we want to talk about acceptance tests because typically acceptance tests are not isolated, and the reason is because there's a difference between integration tests and unit tests, right? You can have integration tests as much as you'd like to, and you're not necessarily going to get by with things unless you are also integrating, unless you're also integrating things together and testing them, right? And so this is to say that functional and acceptance tests typically are showing real scenarios where you're wiring up components to work together. You're not necessarily isolating them, because at the acceptance level, you want to make sure that things are going to be working across the board as you'd expect them to be. So how do functional and acceptance tests accomplish this? So in this case, they do that with what's called the Gherkin syntax, and we'll talk a little bit more about Gherkin syntax. But the idea is that it's essentially a standard for the language of examples. So it came across with cucumber originally, hence the name Gherkin. A little play on pickles, cucumbers, etc. Which I'm not a fan really of either, but it's a nice pun. So the Gherkin syntax involves typically three statements. There's a given statement, a when statement, and a then statement. Now, the given statement sets up the world of the test, and by that I mean you're sort of saying what's happened up to this point to make the test a valid test case. When is typically you taking an action. And taking that action is the thing that you're going to be running your test. That's the action you're taking to assert against. And then is you making the assertion that something should have happened. So let's look at this as an example. So let's think about an old kind of requirement and think about how this may have been phrased in olden times, or when there were when we were developing software previously. So the idea is that they may say a system shall allow login access, right? That's pretty generic, right? A lot of room for interpretation. A lot of places you could things could go back and forth. Maybe you have a big design document to kind of work that out. You're kind of figuring out how to do. You're going back and forth versus something like this, where we say, okay, given I am on the home page and I have clicked the login button. When I enter a valid username and I enter a valid password and I log in, then I should be redirected to my profile page. So this tells us a lot more, right? So what we get from this is, first of all, an example of the starting state. So it's clear what our context is. We're on the home page, right? This test is written in the first person because it is written as an actor of some kind going through the product and performing an action, right? It sort of sets up the universe of the test, right? So, and a given statement can be important for data setup too, right? It could be, given I have a customer by this name in my database, and then you can behind the scenes go and set that customer up in your database, right? But the idea is that these are things that must be valid for the test to really make any sense. So entering a valid username and password doesn't make any sense if you're just on the homepage and you haven't clicked the login button in this case, right? So it shows what has to be true before the test actually work, right? And the when statements, now typically there are different opinions on this. Some folks tend to say there should only be one action, right? Because we only want to test one thing. I tend to group them into one logical action. In this case, the act of entering credentials and logging in. But that's up for some debate. So the folks, if they wanted to, can move that into the given statement there. But an example I used here is, like, say you take this to your stakeholder and you're talking with them about what what we should build or how you should do this. And they say, oh, we don't use username and password. I want this to be a Google login. Right? Well, you just learned a bunch there before you went and built any kind of login system. And granted, yeah, you could try to get ahead of that with documentation. This is a little bit of a contrived example, but the idea here is that this is a set of steps that you could agree on with a stakeholder that when you are done your work, they could go run these exact steps and verify that you had done what they expected you to do. Right? And a human being could read this, they could follow the steps, and they could do that. So the nice thing about this is that can be automated, as we'll show in a little bit. So similar idea here, right, in using very specific language. When we use examples, we don't like to use generic text as much as possible. We want to use concrete examples that we can relate to or that make sense for us. So in this case, a shopping basket, right? So we have a title or scenario, right, for a title of the scenario rather, and then we have our given statement, which in this case, my shopping basket contains 1 copy of Harry Potter. Note, we use a specific book. We don't say a book, right? Because when we can talk about my shopping basket could contain 2 copies of Harry Potter. Well, should it contain Harry Potter and then the number 2 to indicate a quantity? Should it contain Harry Potter and then Harry Potter? Right? We can start to have those kind of conversations about what we want from the story as well. But the idea there is that we say, when I add the book Harry Potter to my shopping basket, then my shopping basket should contain 2 copies of Harry Potter. So we've set up the world of the test. We've executed that action. We're then able to make an assertion about that, and we're using explicit examples so that we can do that. All right. So benefits of this. Mostly, the first benefit is that these things feed back into each other. Right. So our examples are what describe our requirements. Our tests consist of examples, and so our tests verify the fulfillment of requirements. So if we can write our understanding of what should happen in these examples, and we can automate those examples, we've gone a long way to being able to speak to the health of the system and being able to speak to the kind of things that we're going to want to do, or rather to be able to speak to the kind of confidence that we have in being able to execute things or know that things are done in the way that everyone expects. Similarly, you all just had a conversation about those examples prior to picking up the work. So the likelihood that you're going to be on the same page is much higher. And that lets us do something along the lines of, I've seen this used before, the idea of acceptance test-driven development or functional test-driven development, where the idea is that, okay, you've got, say you've got a user story, you've got a checklist of acceptance criteria, right? So the first thing, you take your first acceptance criteria and you write 1 or more automated examples for it, right? So you write your automated acceptance test, which describes the feature, how it should work. That fails because you have no code yet. Then you go through the traditional TDD loop where you build that code up to such a point using unit testing, integration testing, that eventually it fulfills that automated test. Right now, you've got that sort of that inner loop complete of unit test and integration test, and you've got the outer loop complete of the automated acceptance test as well. So once that passes, you know that you can go back and pick your next example or pick up your next acceptance criteria, and that's going to let you move forward, knowing that you've got those acceptance criteria covered. And I should mention that this is a real thing. I have done it on clients before. It's not pie in the sky, I promise. I'm actually working with a client right now where we're doing a lot of this. It's sometimes difficult for developers to get in the habit of writing an acceptance test first or writing from that perspective first. As we introduce that into the overall development process and we start conversations about it earlier prior to picking up the work, you get a lot more feedback on those things and folks get a lot more confident. So just to speak to the benefits of that, as I mentioned, consensus is huge in this case. When we are able to look at the same requirements that our stakeholders have and have the same mental model and know exactly what steps are required for sign off and can prove that we've automated that, it's much easier to hand over a story to a stakeholder and say, we think this is ready for your review. We think this is done. And by the way, here are all the tests that we covered, and they're all the things you told us it needed to do that we all agreed on. So that kind of consensus is really powerful. It's also powerful if things change, right? So I'll talk about in a moment. I mentioned starting things earlier in the process, right? That tends to be a great way for teams to move faster. When you get consensus on something earlier in the process, right? And we can shift all of that conversation to the left and all of that discussion about requirements and sign off and how are we going to test this and what do these things actually mean? When that stuff happens at the beginning, rather than when we develop a story and then say, hey, stakeholder, we think it's ready for review, and then it happens and it has all that churn, right? Doing that at the beginning on the left-hand side of the process, so to speak, is much more effective and efficient than doing it later on, right? So we can sort of break that cycle of those mini waterfall steps and break that cycle of that churn that happens late in the conversation. So when things come up or when these stories are automated, really there shouldn't be many surprises because we agreed on it up front and it's been automated. So if there is something that went wrong, then we have a very specific thing we can address. So I mentioned it makes sign off easier. So you have that agreement plus automation, right, which equates to more trust, more confidence. The one I like in particular is the idea of missed requirements. So when a story goes to your stakeholder for review and they say, oh, it actually should have done this, it makes it a lot less blameless to be able to adapt to that as well. Like, okay, so a couple of things happened. One, we all missed this requirement up front because clearly there wasn't an example for it. It wasn't documented. And we have a clear route for what we can do. Okay, if we've got the ability to add another scenario and test that and add the code to do that, we can do that right now. Otherwise, we have an example, right? We can say, okay, what's missed? And we put it in the given when then format. And we put it in our backlog to address later. But either way, we have a concrete example, a concrete understanding, and we are able to sort of capture those requirements in a more blameless way. And we have some feedback on what we can look at in the future when we're thinking about requirements or thinking about how something should work, and that it's a collaborative process. So whether it's your product owner or your developer, or if you're working with a QA team or your QA team member, like any of those folks can say, hey, I think we might be missing an example here, a scenario here, or have we thought about this scenario? So having the ability to address those things, holistically as a team is really powerful. And so from here, we'll go for a little story time. So I guess I should probably take Elmo off the screen. Okay, so just we'll go there for a second. So just quick story time before we go further. I was working on a retirement system, a retirement benefit system, handled around $7 billion, I think a little more than $7 billion, annually in funds. And we had over time we had modernized this from a mainframe system. However, there were also several product owners, several stakeholders, right? And it evolved along the way. And when we kind of got to there, or when I sort of got there, it was a little bit of a mess in some ways. We had, in many cases, it was a well-factored application, but in many cases where that legacy logic was ported over, some of it was a mess. It passed their test cases, but it wasn't necessarily pretty code, right? So there was a piece of that code called a participation engine, or a eligibility engine, essentially, that determined who was able to have what benefits. And so after we went live, that became one of the pieces of code that no one really wanted to touch. Like, yeah, there were unit tests, but there were a bunch of different stakeholders who had input there, and we weren't 100% sure how to regression test that thing. And so along came the requirement, lo and behold, as it's a modernized application. Let's support a new kind of retirement plan that does participation and eligibility in an entirely different way, right? So okay, that's going to be a possible nightmare. They had allowed for, I think, 6 to 9 months for regression testing alone. And so because in many cases, they said, well, we're not entirely sure what the system does now or what it should do. And so we said, okay, well, let us try something. So we'd ask them for some examples of folks and what the rules were. And we started repeating it back to them in the given when then format. Right, and then we went and we'd automate it, we'd prove it out, and we'd show them, hey, we automated that this did it. Right, and the first couple were painful, but we were able to start reusing the language for future examples. And the team, the stakeholders were seeing these examples be built up, and they thought, oh, that's really good. Like what about this? What about that? And we were able to start accommodating those examples right in front of them. In some cases, using like autocomplete within our IDE and writing the test right there in front of them. So the stakeholders got more comfortable instantly with the process because they were able to use their own language around testing and acceptance and examples, and we were able to convert that. By the end of the process, they were speaking in Gherkin syntax using given when then terms, and they were able to move forward. And I say this because the end result there is that we took the time to do that upfront, to really document what the system did via those examples. And by the end, we had 3,500 examples. It took mere minutes to add an additional example if someone had an idea. And even if it was a duplicate, at that point, fine. What does it matter, right? Additional coverage, right? Put the sample in there. So we had 3,500, probably a little more than that, actually, tests. They took a little while to run because they were acceptance tests. They required an actual database with a data load and some other things, right? So they weren't exactly like the cheapest to run and get feedback on, but we had the confidence and the coverage. And I mentioned this because the sign-off period for that was reduced from 9 months to something like, I don't know, I think it was like a couple days or a week. Because once we had those tests in place, we knew that all those examples would always pass and we could accommodate new examples. That made the code safe to refactor. And sure, we had to do some unit testing work and some integration testing work as well to support that, and we had to refactor the code to be cleaner. But we had those examples, those overall examples in the language of acceptance that let the customer feel confident that we can move forward quickly. So saved a bunch of time, saved a bunch of money, saved a bunch of aggravation, and made me a real believer of acceptance-based testing. So what does Specflow do? Where does Specflow come into the story? So we've talked about the generic idea of acceptance testing, Gherkin syntax. So Specflow serves as a glue in a way. It serves as a glue between the human readable sentences of Gherkin syntax, given when then, and automated steps that you take in order to execute those human readable sentences. So it generates tests behind the scenes in existing test frameworks like XUnit or NUnit. So, and we'll take a look at examples of this. We definitely got some real world stuff to show you. But a quick example is the idea of, like, say we had, I think in this case, the idea was a vending machine, right? So a little bit of a contrived example, but given there is no money in the machine, And then Specflow might map that to our release change method, which sets the change to 0. When I insert a coin, Specflow might execute the insert coin method, which sets the change equal to change plus 25. And then, so then the balance should be 25 cents. Or if you're a QA person, you've already caught the typo in that picture and said that's not 25 cents at all. But the balance should be 25 cents. And then that might map to an assertion that the machine has a balance of 25. Right, so Specflow, that automated acceptance test runner, serves as the glue between those steps, and it's got a lot of really nice syntactical sugar and conversions and things that help. So that's enough of that. Let's see some demos and let's take a look at what we can do here. So here I've got a solution here for a project that we're going to do from scratch, where we'll demonstrate some of the Specflow capabilities, and then we'll also go through some other examples that we have that are a little bit more than basic. So I want to show you kind of how to get started running from scratch with a Specflow product. Now in this case, let's see. So in this case, we've got the Specflow extension for Visual Studio. So that is an extension that I've installed here. You can get it again. One thing I should mention: Specflow is okay. Visual Studio, sure. One thing I should mention is that Specflow is free and open source, which is pretty darn awesome. So one of the nice things there is if you want to get involved, you can, and if you want to support them, you absolutely should. So Specflow for Visual Studio 2022 is here, and that's something that's going to help me get syntax highlighting and some other really nice stuff in my IDE experience. So that's first and foremost. Then we're going to install some packages in this case, my from scratch project here. So let me just go to Manage NuGet Packages. And I'm going to go ahead and browse for Specflow. So we've got a couple packages that come up, and I'll go through it real quick. Anybody want to venture whether we should use XUnit or NUnit? In this case, I'm completely impartial. I'm happy to work with either. Any preferences? Shout it out.
XUnit.
Thanks, Matt. All right, so with this, we're gonna install two things. We're going to install Specflow here, or Specflow.xunit, which is going to install Specflow, the MS build generation piece, XUnit, and the skippable fact piece of XUnit. And actually, that might be it. You used to have to install separate packages, but I'm seeing they have the right dependencies. So this may have gotten easier since the last time I did this. Let's go ahead and install it. Let's go ahead and install Specflow.xunit. Right, we'll accept all the licenses without reading, just like a good developer. All right. And so now I've got, just double checking, in this case, we're going to use XUnit, so we're not going to worry about the NUnit pieces. All right, so I think we've got everything we need. Let's see if we actually have everything we need. So I'm going to go into my from scratch project. I'm going to add a new file. One of the things that Specflow gives me is the ability to add a feature file in this Specflow category over here. I've got a feature file. Let's do something super basic. We'll do something like a calculator, right? So I'll call it the feature is the ability to add numbers. Right, so I'll call my file add numbers.feature, and this is just a text file you can rename, but Specflow gives you nice syntax highlighting, and nice to create it through the wizard there. So what do I have here? We have a name of a feature, which I can change to I can add a space there, a short summary of the feature. So I could say as a math dunce, or as a math learner, we'll say I want to add 2 numbers so that I can be sure I've got the right result, right? Not exactly the best user story syntax, but we're going to bear with me here. So now I can do something where I say, scenario name. So let's say scenario name. For now, we'll skip right ahead to add 2 numbers. Given a first number of 1, when I add, let's see, when I given a first number of 1 and a second number of 2, when I add the numbers together, then the result should be 3. So that's a human readable sentence, right? I think we can agree that that's fairly reasonable. I'm going to go ahead and hit build on this project here. What we should see here is that you saw those scenarios turned purple. Specflow detected my build, and it detected that these stories are not mapped to any steps. And we'll talk about steps momentarily. So given a first number of 1, I'm going to hit the F12 key, which in Specflow, right, or in Visual Studio is the go-to definition. Specflow is helpfully going to jump up and say, this step is undefined. Would you like me to copy a definition to the clipboard? Well, yes, I would, Specflow. That's very helpful of you. So now we need to kind of start automating the actual production of these steps. So let's go ahead, and I'm going to rename my class 1 here to, add numbers steps. All right. And in this case, to make Specflow, to make these steps available to Specflow, it expects you to put an attribute called binding on your class. This will make these steps able for Specflow, or make Specflow able to map these steps to their definitions. So let's go ahead. I'm going to paste what Specflow sent me. So given a first number of, and then it helpfully uses some regex syntax here to capture a variable, and then it will map that into my method here, which is very, very helpful. So given a first number of, I'll say int p0 is not really a great variable there. Let's go ahead and call that first number. And so I'm going to go through and let me just add all these first, and then I'll go ahead and copy. We'll fill them out when I add the numbers together. We'll walk through this together here. Result should be 3. All right. So, and actually, for the sake of this project, and just because I really enjoy it, I'm also going to add fluent assertions, just because I enjoy it, and life's too short to not do what we enjoy. All right. So I've got our step definitions here, and while that package is installing, let's go ahead and think about how we might make this work with a local class here. So we've got our add number steps. Given a first number, well, let's capture that in our state, right? So let's have a private int first number here, right? And when we capture that, we'll say first number equals thank you, IntelliSense. Right. So now we've given a first number of that, and all we're doing is setting that variable, and a second number. Well, I think you see where this is going. Right, and a second number of that. And let's go ahead and rename that variable. And when I add the two numbers together, okay, well, in this case, right, we'll have to probably set a result variable of some kind. So let's go ahead and private int result. And let's go ahead. I guess fluent assertions isn't available. Okay, cool. We'll figure that out in a second. When I add the numbers together, we'll say result equals first number plus second number. Then the result should be, we'll rename this to int. I'll say expected result. We'll say assert. What is the X units? It should be assert, no? I will say, since using them enough, I get confused between should I use assert dot or oh, this is going to be embarrassing. I can't believe I forgot the X unit assertion syntax. And maybe that I haven't added X unit explicitly, actually.
I think that's what you have to do.
Yeah, that's
every time.
I realize. Yep, implicitly, it's Specflow is building the X unit test behind the scenes, but in order for me to actually reference that, I've got to add X unit, so that's on me. That makes more sense, at least.
I too learned that fact when presenting about 2
always the most fun place to learn a thing.
Yeah.
In the middle of or to remember a thing. Okay, so for example, now I've got the X unit assert, right? So I could say your assert dot equal result expected result. Expected result, and then the actual is the result there. So one of the things we didn't see, but I'll use ncrunch actually to go ahead and I'll enable that for my project. And ncrunch, by the way, is a great tool. Another tool I'm very happy to pay for. It costs, I think, $200 a year, something like that. And I am grateful for it all the time. You can see it adds a little test runner down here. It runs all my tests automatically. It gives me some highlighting next to the code, which is great because it works for Specflow as well. I can highlight, I can hover over and see the passing there. So I can go ahead, and if I look at this class, I can see those tests are all passing. Those steps are being executed, and our test is working. Now, if I said, let's just say second number equals, and we always said 2, right? We always said 3, right? We can see that our test runs, that fails because the assertion wasn't passing. I can go back and get the intelligent highlighting there to see those. So if my code wasn't doing what it should, we could actually see it. So that's just a quick example here of being able to add that. Now let's say I wanted to just for the purpose of this, I'll say add 2 other numbers, right, or something like that. It would say given. I'll type given. And we can see I have some, it's a little small, but I actually have some IntelliSense here. A first number of blah and a second number of blah. So I can actually reuse those steps. I can tab across and see that. So first number of 5 and a second number of 8. When I add the numbers together, then the result should be 15. Go ahead and watch that pass. And so now I'm able to reuse those steps pretty quickly. And one other feature also, just in this specific example, is the idea of a scenario outline. So right, these two tests are kind of the same test, right? We're just testing adding two numbers together. So let's go ahead and refactor actually to a scenario outline. A scenario outline can provide examples. So let's go ahead and say first number and second number. And let's say that our first example, expected result. Our first number is 1, our second number is 2, therefore our expected result is 3, and our another scenario is 5, and 8, and 13. I'll get rid of this test here, and I'll use placeholders in the syntax rather than explicit numbers there. Helps if I spell it right. And we should see that test should run again. What am I missing? The string is an incorrect format. Ah, okay. So
Probably the casing.
Probably the casing, right there, right? And so that's great question. So what happened is it got mapped there. It got mapped here and it's sent in the text of expected result. And so it couldn't convert that to the int that I expected. So I saw a string format error there. So that was, Specflow trying to be helpful, right? It caught my error for me there. And that was a little faster than I was to get there, but it caught it for me nonetheless. So that's, so we can use the tables that Specflow provides and the ability to use table objects and to have it convert things for you is really handy when you're trying to map those human readable sentences. So just want to give you, that's a quick example here. And then let's go ahead and let's imagine the idea of a vending machine. And so what we're doing here, just double checking here. So what we're going to do here is the idea of, I'm going to show off some other features of Specflow. And in this case, we're going to assume a vending machine in a very contrived example because I don't have a ton of time to present this. But what we're going to say is, right, so we've got our feature again, right? We can list products. As a vending machine administrator, I want to understand the product. So we've got a user story there. We have a scenario. The scenario is probably not the best named, right? Product count, not really a very descriptive scenario. But we can say, given I have the following products and we have a product name and a cost, and I'm at the vending machine, when I get the product count should be 2. So let's look at how that's happening behind the scenes. So given I have the following products, can actually take in something in Specflow calls a table. So there's a table object in Specflow that it knows how to map things to, and you could iterate through those columns to get the values yourselves, or you can actually have it create an object for you where it will auto map the properties. So saving a ton of boilerplate code. So what we're doing here is we're saying Specflow from that table create a set of products, right, which map to that name and price field there, and then create a list of that. So I've set my local list of products to that. So given I am at the vending machine with the products, we can see vending machine equals new vending machine, which passes in that list of products. When I get the product count and I call get product count on vending machine and I save the result, then the product count should be, and we have an assertion there for the product count. Right, so just another example that being able to use tables there, a Specflow concept of tables, and being able to map those even to a list of products or a list of of objects of your definition, and Specflow kind of taking care of abstracting away a ton of work for you there in what you might otherwise have to do manually. So I like to point that out because I think it's a big feature of Specflow. Similar, let's see if I just had another piece here. Given I receive a product and given I'm at the vending machine, when I insert a quarter and I purchase the product, then I should receive the product. And so this is another example of just in our vending machine here. Given I'm at the vending machine, when I insert a quarter, when I purchase a product, I should receive the product. In this case, we're just asserting whether something is null or not null in terms of the result that we get back. So that's all good, and these are local files. But actually, I'm going to pull up an example here. We have this given I am at the vending machine. And then in our other step, we have given I am at the vending machine with the products. Well, that sounds an awful lot like the same thing, right? And that's probably not helpful to be reusing. We probably want to have those two things be the same. But we're using local variables here, right? Like we're using variables in these different classes. How is Specflow going to know how to access those things? And the answer is it totally won't. It's not going to know how to access those things at all because those variables are stored in 2 separate classes, and all the step files are sort of bound together and able to be used at once. So how do we share that context? Well, Specflow has a great concept of something that you can pass in called contexts. So I'm going to create my own class here. I'm just going to call it vending machine context. Right? I'll do that, and let's go ahead and public. So we'll create that class. We know we're going to need a vending machine. So vending machine, right? We're going to need a product there. So actually let's do public. We're going to need those properties, right? Public product. So we're going to need to access those things. And let's go ahead and say, okay, when we create this vending machine context, when we do that, we want our vending machine, we'll have to pass in, or we want our vending, we'll have something called set products as well. So we'll do vending machine equals new vending machine, right? And then we will go ahead and say, let's see, vending or set products. So this is our sort of a helper class that we're going to pass into our tests here, and we'll say list of products. And then we'll reset the vending machine at that point and say vending machine equals new vending machine with products passed in. Sure, we'll import the list class. And so, right. We should make that able to be set there. What am I missing here? Simple. Right. Wrong thing. That would be helpful if I actually use the right property. Okay, so now we've got this idea of we can set products or call these things. So how do we get that context into our machine or into our scenarios here? So first we're going to in our vending in the constructor for our steps class here. So public vending machine product steps. We're going to pass in a vending machine context. And then rather than these local variables, we're going to depend on a private context there that we use. So we're going to take these things away, right? So given I'm at the vending machine, really doesn't need to do anything, right? So now we don't need to do anything because we've already got a vending machine that's newed up there. When I insert a quarter, we'll say context. Instead, we do context.vendingmachine.add 25. Right, so we're going to go through here and essentially say context.product equals vending machine dot context dot vending machine dot purchase product. So we're sort of we're just doing that refactoring here to get that into the right place. I'm going to go ahead and copy that. So we're going to have to do this back and forth typos a bunch. So similarly, so we've got once again our tests are passing here, and we'll go ahead and do the same thing in the list product steps. So we can take in the same context. Now the cool thing is for a scenario, Specflow is going to make sure that your scenario all shares those same contexts. So that's a guarantee that Specflow will have for you, which is super helpful. So we'll do the same thing here. Create that. Okay. And so we'll go ahead and again remove those things. So we'll set appropriately here. Right. And so what I want to point out here, so we don't have the idea of products here. We can probably still keep that actually, right? Because we can still, that's only local. We don't need to share that really at this point. Right. So I'll leave that in there. Okay. And so what I want to show is that these tests should still pass. Context.vending machine. I'm sorry, context.vending machine equals vending machine. That's not right. Product counts equals context.vending machine.get product count. So we can still save that, or we could add those fields to our context if we wanted to, right? So as we discover that they need to be shared, we could do that as well. So context.vending machine that get current product. Similarly, we could do that here. All right, so we've got that. Now all our tests are passing again. Plus, we should be able to remove the idea of given I'm at the vending machine with the products, right? So now, given I'm at the vending machine, so what we could do, I'm just working this through, and I'm doing this example live because I just thought it'd be an interesting one to show. But now what we're sort of faced with is we want to sort of take those products here. And so we'll change this to given I'm at the vending machine, we'd always use products as part of our, that's what we'll do. We will always use products as part of our vending machine context. So we go to that definition, right? So I'll do public list of products, because it's the context, which is fine. List product products, right? And then we'll set at the beginning when we're instantiating this, we'll say products equals new list of products, and vending machine equals new vending machine products there. And then when we set the vending machine context, we should be able to remove, oops, sorry, when we set the vending machine context for the feature, we should be able to remove given I am at the vending machine, which will have an empty list of products, and then the list products feature, oh, sorry, it's going to fail because of course I removed a step. So we can say, we can rename given I'm at a vending machine with the products in our list product steps file. Oops, in our list product steps file, then you can rename that to given I'm at the vending machine. All right, now we'll have some failing tests to deal with. Let's go ahead and go back to our feature steps here. Oops. I can go see my ncrunch test list, which tests are failing here. I can go to product count. I can see on the scenario, the product count should be 2. It's looking, this one is not passing because the step doesn't exist. So let's go ahead and update those steps. We can see if those tests are passing again now too. So I wanted to mention here, there we go. Let's go ahead and build again. Got caught in the middle there. So what I want to mention there is mostly that you can have these shared contexts that are shared between steps. There's also the concept of things like before scenario and after scenario, where you can do setup and teardown style activities. And so we've definitely had in the more complex Specflow scenarios you might have a context that includes a current database connection, or a context that includes a list of users that you might be operating on, or a security context that you're operating in. And you can have as many of those different kind of context classes as you'd like that can help you in the creation of those features. So that's really what I had for tonight. I wanted to give you a quick tour of the Specflow runner and the Specflow syntax. But I'd love to open it up for now and see if you've got other questions or what else you might have on your mind for me as far as Specflow goes, or if there are any questions in the chat.
Is there any dependency for framework? Will this work on both full framework as well as older core versions?
I haven't checked in a minute, but it should work on both. Last time I checked, it did, although I should admit that was like a year ago. Let me see if I can find that answer right now. I believe it supports both .NET Framework and .NET Core and beyond. Requirements. It is supported. Yes, it supports .NET 5, .NET Core 2.1 and 3.1, .NET Framework 4.6.1 or greater. It'll work on Visual Studio 2017, 2019, or 2022. It'll work for .NET Web development, desktop development, or cross-platform development. So it'll be available in all the places that you might typically need it to be. It's a great question.
Nice, thank you.
Mm-hmm.
Hey, Sean, it's really great to see you, man.
Good to see you too.
It's been a minute. At the beginning, when you created your feature file and you started writing your given win-thens and everything turned purple, and then you had to generate the C# classes behind that, that seemed like a lot of just kind of cut and paste boilerplate kind of stuff. Is there any way to automate that step?
Not that I'm aware of. I think now it may be, I didn't try, for example, in the feature file, just seeing if I could like F12 on the feature. I don't think I can do that, but I think that you can F12 on the steps themselves. I will say it seems like a lot, and at first it may even be a little bit. I wouldn't get too intimidated by it. I find that I am able to move pretty quickly after it, especially with like the F12 helpers and so on and so forth. The other thing that I don't mind so much about that is that it forces me to kind of be pretty conscious about what I'm doing with when I'm thinking about the test and I'm thinking about, okay, what am I testing? And I'm going through those steps, like being present and engaging with like, okay, this is exactly what this step is doing, and I'm thinking about it. Personally, it helps me, so I don't mind it so much. As far as I'm aware, there's no way of doing it all at once though.
Yeah, because what I've been doing over the last little while at work is I'm trying to automate the loop from Azure DevOps and people entering acceptance criteria in Azure DevOps for that to automatically create feature files in our Git repos. And then I want to automate as much of that as possible, so the devs just do pull, boom, there's a bunch of unit tests and all that.
I see. In this case, we sort of do it the other way, where we're generating tests, and then we might generate the documentation from those tests that we're building. And in fact, that just your question, which is a good one, made me think of another quick piece of tooling that I can share. So I'm just going to pull up a console window here, and let me just go to code file here. I'm going to install a .NET Global tool here, which is called specflow.plus.livingdoc.cli. So Specflow has the ability, it's already installed, which makes sense as it would be. So Specflow has the ability to generate a document based on these specifications. So I'm just going to go ahead and run that real quick. And so this might be something that you want to do as part of your build process or as part of your test process. So we can see there was a full document that was generated here. I'll pull that up, and I'll pull up my living doc folder here. And we can see a web page is generated. Now, obviously, there's not much to look at in this place, but we can see the code folder from scratch. We can see the features. It shows us a nice understanding of like what the outline is. We can show the different examples that are added for it, and it'll actually populate those examples if I select them, so it can show what we're doing there. You see examples where you can show the preview and toggle that on and off as well. And there's also the idea of analytics, where you can connect this to the output of your test runs, and it'll give you analytics on like how many features you have, how many scenarios have, what all the different steps are, and it'll let you search for them. And there's something about that. There's something a tool called Pickles that will allow you to do that as well. But I wanted to point out that it's a doable thing there from a Specflow perspective.
Have you ever managed to hook up any kind of Specflow test to a kind of a UI driving test, like a Selenium test or a robot framework test or anything like that?
Another great question. I should expect no less from you, Matt. But another great question. Seriously though, the pieces here are. Yes, essentially, yes, you can. And there are examples on the Specflow site of folks doing that with Specflow or doing that with Selenium, doing it with Playwright. And in fact, I prefer that for UI style tests, because so often you kind of have tests that say, tell the browser to do something, but it's not necessarily connected to like the human intent of doing the thing. And so what I really love about Specflow is you can say, given I'm on the homepage and that steps file takes in the Selenium browser context, and given I'm on the homepage, you can redirect, or the page object model or whatever you might be using. And that given statement can then map to a command that tells Selenium to locate the homepage, right? And as a before scenario step, maybe you verify that your web server is up and running, or you start your web server or something like that, right? So definitely you can use it in conjunction with UI-based testing tools, and I certainly would encourage you to use it with them rather than do those things on their own, because I think it keeps the examples like way more fresh in terms of what you're doing, and it maps it back to like real features and functionality. I always say that with a bit of caution of like, okay, I also don't recommend necessarily doing all your tests as UI tests if you can avoid it, right? Because there are still complexity trade-offs and maintenance pieces there, and they're a bit more fragile. They take much longer to run, et cetera, et cetera, et cetera. But if you are doing UI tests at that level, and that's where you're sort of operating at on the testing pyramid, so forth, then it's definitely a viable way to do that.
Yeah, like I said, I'm just trying to figure out how to automate as much of that loop as I can, where they start with acceptance criteria and you end with documentation.
Yeah, absolutely.
That would be the goal. All right, thanks, man. Appreciate it.
Yeah, sure, absolutely. What other questions do we have?
You're just that good, man.
No, well, but I will say, I hope if nothing else, I hope I've helped plant some seeds for conversation across your organizations, because I have seen time and time again that being able to collaborate on these things and being able to to operate in that way, where you have that clarity, that shared mental model up front, it really does start to help things go faster. And I titled this presentation "The Joy of Functional Testing," or the joy of automated testing with Specflow, because I have seen it increase. Now, maybe joy is a bit of a stretch, but I have seen it increase happiness, and I have seen it increase collaboration on teams, because if there's a question, you can go read the human readable things and figure it out together, and it gives us the ability to sort of build on those things very rapidly. So if nothing else, I hope that you'll consider that for future testing endeavors as you work into it. One last tip that I have is that this should be, I find that these are best saved for areas where acceptance testing makes sense, like where an external stakeholder might be asking you what the application does, or where you might be talking about a very important piece of business logic that someone might want to understand. I would not use Specflow to replace all of your unit tests, for example. I think it ends up being cumbersome. It doesn't really explain much. You're not really getting much out of it at that point. So it really does, for me, Brett, when you're getting to the level like using acceptance language, or the language of how you would explain this to someone externally who maybe isn't a developer. When you get to that, or isn't a coder, I should say, when you get to that place, Specflow is incredibly helpful. So that's the last caveat I'll leave you with. But hopefully it just took you to someplace new on your testing journey. And I will mention I'm always available if you've got questions or concerns, or you want to follow up. Feel free to reach out to me anytime. And really, really appreciate the opportunity to talk tonight.
Great. Thank you very much, Sean, again, for coming and presenting for us. I think this was very enlightening. I'm used to doing basic simple unit tests that this definitely adds a level of to the testing that we could be doing. And I really like the fact that this is something that I can just give the product owner and say, hey, here's all of the requirements that we built in directly to the product, so you can be assured that your needs are met. So
there's something to be said about the transparency of, you can see all the things that we see. Yep. Right? You can see all the steps that we're using. You can see exactly what's being executed. You can go through a step and we can talk about it anytime you want. Like there's definitely that collaborative, trust building, transparency kind of aspect to it, for sure.
Absolutely. Next session up is first week in August. It's going to be August 4th. We'll be joining and we will have Mr. Scott Hunter presenting from Microsoft.
Well, it's going to be tough for him to follow this one, I'll tell you, Scott. I know
he has no chance, but he'll do his best. I'm sure he'll do his best, and it'll be okay.
He is a lesser Scott, so I mean, what the heck?
Happy to be in such good company.
That's right. That's right. Hope to see you guys all again there. Until then, keep on learning.
Quick question, Tolga. You mentioned at the beginning that this was going to be put out on YouTube. Will we get a link? Will you put that in the meetup, or will will that get sent out?
Yes, and let me put a link here right now, which is the newsletter, and you guys can sign up for that newsletter as well. The newsletters have like the last few presentations in them, and you can go watch the last few, and then you'll know where the site is. Let's see.
That'd be great. Thank you. I want some of the people I work with to see this.
Yeah, it's great stuff.
And like I said, anybody's got questions or follow-up, feel free to reach out to me anytime. I love talking about this stuff, and then always happy to continue the conversation.
Thank you.
All right, thanks everyone. Good night.
Yep, thank you, Sean. All right, I posted the link right there. If you click on that, you'll see the newsletter for the presentation that you guys just seen. And at the bottom there, you will see a few of our past presentations. And if you click on there, you will find our YouTube channel that this video will be posted on.
Awesome. Thank you so much.
Thank you.
Sure. Thanks for joining. Okay.
Thanks, Sean. It was great.
Have a good one. Bye-bye.
Bye, guys.
Thank you.